Great. Hi, everyone. My name is Sarah Moliner-Roy, and I am a research engineer at VivLab's Samsung Electronics. It's my pleasure to be with you today to talk to you about Bixby development and to show you some building blocks to help accelerate your capsule development. So we will talk about Bixby templates, library capsules, and sample capsules, which are all ways to get you up and running faster at Bixby development. And just real quick, for those who are unfamiliar with the term, when we say the word capsule, it means essentially an application in Bixby. So the entire experience that the user will go through in accomplishing their goal, and from the developer standpoint, a capsule is all the code, the training, the resources that are involved in making this experience possible. So let's start right away with Bixby templates, which is the shiny new tool that we're excited to reveal this week at SDC, so you can be the first ones to try it out. Essentially, Bixby templates is a wizard that allows you to generate a capsule from scratch. It will walk you through a series of questions to understand the experience you're trying to build, and then based on that, it will generate all the code needed to have a fully working end-to-end experience that you can then build and iterate upon to customize as you'd like. So let's jump straight in to the Bixby Studio, and I'll give you a demo to show you how that would work. All right, so this is the Bixby Studio. When you first open it, you'll notice that now there's a new way to create a new capsule. It's called Create New Capsule from Template. And this brings you to a list of different templates that are common user experiences that we've observed people want to build. So for example, you could build a jokes template and pick your language, and it would ask you to fill in your jokes, so knock knock, and so on. I could go back to the templates, show you the podcast template. This one would ask you for a URL that it would then use to create a streaming capsule where the user could ask to play the audio. Another one would be a quiz template. This one would have you enter a bunch of multiple choice questions, and then it would walk the user through answering the quiz and tallying up the score. But in some cases, you'll probably have more data than you'd want to enter manually in a wizard tool. So for those cases, there's other templates that allow you to import the data. For example, the search template lets you import the data from CSV files. So what would this look like? Well, here I have a spreadsheet with data around movies. It has the movie name, images for the movie, a list of actors, and a description. The actors are just IDs because there's a many-to-many relationship between movies and actors. So it wouldn't make sense to add all the actor information here. It would get repeated too many times. So instead, I have a second spreadsheet with the actors, this one keyed by ID, with the names of the actors and their profile image. So what the wizard would do is it would look at both of these files, and it would analyze everything that's available for it to look at. So it would look at the headers, and it would infer based on the names of the columns what type of search experience you're trying to build, what are the concepts that are involved. It would also look at special annotations that you can add to explain the cardinality of these concepts. For example, the star, similar as in regular expression, the star means zero or many, and these symbols can be put before or after the name of the column to explain to add the constraint to either the input side for this concept or the output side for this concept. So then it would look at the data underneath these headers and see, for example, the ID appears to be a number, the name is a string. It would even look and analyze the strings and see that the poster image, because it ends with this file extension, is probably an image. It would see the list of IDs and cross-link it with any other table that we add. And it would even identify more complex types So these are all primitives, but you could add money, price ranges, you could add addresses, you could even add times and dates. So let's import these spreadsheets and see what the wizard comes up with. So I'm going to upload the CSV for the movies here. It's the same one I just showed you. Call it movie. I'll add a second one. That's the actor one we just looked at. And call it actor. Whoop. Hit next. Now it's just asking for a name for the capsule. You can always use playground to play around. Hit generate. And already within seconds, we have a fully functional capsule that was generated for us. So we have models. The primitives were inferred from the columns we just looked at and created as needed or pulled from other library capsules. We'll talk about library capsules later. The movie structure was created to loosely match that movie spreadsheet. You see that it has a property that is an actor. There's also an action that was created to find actors based on their name, and then an action to find movies either by name or by actor. So these two actions could be chained together to produce movies. Then in the resources, we have our layouts and views that were generated. We have our dialogues. We even have vocabulary that was bootstrapped from the data, and just a few sample training examples. So this is where you can come in and teach Bixby how to connect all this data that it saw with how you expect users will inquire about this data. So this is where the human language understanding becomes super important. So we're going to teach it how to understand English, essentially. So we could say something like, in what movie does Sophie Turner star? And we add this training example. The goal is a movie. And amongst all these words of the English language, we want to teach Bixby to recognize that this right here is an actor name. And we would go on, and we can expand the plan graph and see that it's connecting the value inputs, the actor name, to the goal by going through the find actor action as well as the find movie action. So this is good, this is what we want. So we could save it, keep adding examples, and then compile our capsule. And then jumping into the simulator, we could ask Bixby, show all movies.
Here are some movies.
And it would pull out the data that we imported and correctly slot the data into the right Bixby views that it thinks are appropriate. So it did identify that these were images and put them in as thumbnails. Or we could say, in what movie does Will Smith star?
Here are some movies.
And this time it went on and filtered the movies, and it even created a detail view for every single movie, which pulls in the actor data from the other table and gives us a list of the actors along with their image and does the whole layout for us. So this sums up Bixby templates. I encourage you to go and try it out, throw whatever data you have at it, and see how it handles it, and give us your feedback. Now I will go back to the slides. And we can move on to library capsules. So library capsules are essentially building blocks that you can use to create your own capsules, and they will working with higher level abstractions so that you don't have to do all the work that's handled already by the library capsules. So for example, in this movie search capsule, if we wanted to add a new feature to be able to filter the movies by release date, or to display the release year and date of those movies and the runtime in minutes of those movies, we might start trying to model this by naively adding all the concepts one by one. So there's a year, a month, a week, but then very quickly you'll see that the time domain is very hairy and there's a lot of complexities in it. So users could ask about holidays, they could ask for different languages, there could be time zones, which are super complex to deal with. For example, if someone were to say, le dimanche de Pâques in French, you would have to know that this maps to Easter Sunday in English, and that's calculated as the Sunday following the first full moon of spring, and then you'd have to somehow resolve that to April 12th, 2020. So the time library will handle all this complex knowledge for you and provide the expert domain knowledge so that you can focus on what you do best, in this case, the movie domain. And as a side effect of this, you get a great separation of concern, which is really an engineering best practice. All your code in your capsule is focused on movies, and everything related to time is encapsulated in the time library. And this makes it much easier to maintain your code moving forward. Another great benefit is that library capsules are easy to use and to reuse. So once you've figured out how to handle time in the movie capsule, you might want to build your next capsule, space resorts or weather, and also use time, and you would just follow the same patterns that you were using in movie. And even other library capsules can use the time library. So all the capsules use the same patterns to deal with these complex concepts, and as a benefit, the end user will have a consistent experience across capsules. So everywhere that they're asked for a time, it will be prompted in a similar way and understood in a similar way as well. So all in all, library capsules are there to save you both space and time. So what are they and how are they different from end user capsules? So an end user capsule obviously is targeted at the consumer, the end user, who talks to it and invokes it by talking directly to Bixby. Even from a resting state, they can wake up Bixby and talk to that capsule directly. Those capsules are published to the Bixby marketplace, and in terms of scope, they are broader than the library capsule, and they're all about getting something done. They're action-oriented, and they have all the natural language training that allows to carry the user from start to finish in accomplishing their goal. On the other side, the library capsules are targeted at capsule developers like you and I. They are shared and documented in the Bixby Developer Center, and they are imported in code by other capsules. So their scope, as we saw, is narrow and deep. They provide expert domain knowledge. They handle all the edge cases, and they are translated across languages. In terms of natural language, they only provide specialized language. So you can't just wake up a library capsule and talk to it. But by importing it in your capsule, you benefit from all the specialized training that's in the library capsule. So if, for example, there's a prompt for one of the concepts in the library capsule, the user can answer it, and on your side, if you imported that library capsule, you don't need to add any training to deal with the user's answer at a prompt. How do you use them? Well, BixbyDevelopers.com has a list of all the library capsules that are available, along with their recommended version. So all you have to do is to open the capsule.bxb file and import the capsule. You declare the version you want to use, and then you can give it an alias, which will become the handle that you use to refer to that library everywhere else in your code. We also provide this neat dependency graph across the library capsules. So how does that work? The way to use it is you identify all the library capsules you want to use. For example, if we wanted to use geo and time here, we would find them in the graph, see which one is the highest in the tree, and then we would import that one with its direct version. So import viv.geo, version 9.20.3 as geo. And then everything below that capsule in the graph, we could import transitively using the version from keyword. So we could import viv.time, version from geo, as time. And there's two benefits of doing this. For one, all your library capsules will be using the same versions, so they will be cross-compatible and can pass models across to each other. And then secondly, when the time comes to update your versions, you only have one number to change. You don't have to change every single import's version. You just change one and everything follows. Some of the library capsules will give you access to sensitive user data. If that's the case, you'll have to explicitly request a permission, and the user will be asked to grant that data, and they will be able to revoke it at any time. So use it wisely and make sure to handle the case where the user refuses to share this information. So moving forward, you'll be able to use those library capsules everywhere in your capsule using those aliases that we declared earlier. So I think the best way to really see what that means is to go through an example. So here I'll show you how to integrate the time capsule into the movie search capsule that we saw earlier. So first you'd want to look at the time library and get familiar with the models that it provides. So there's hundreds of models in the time capsule, but really these are the few that you would want to be aware of. There's all the obvious ones in orange, things like a year or an hour, and then they are grouped together into obviously a date and a time. In terms of special naming though, the time capsule will use the word date time to refer to a date tied with a time. And then it will use the suffix interval to describe a concept that can have an optional start and end. So the two that you should be aware of are a date interval, which has an optional start and end date, and a date time interval, which has an optional start and end date time. And now the great thing about the library for time is that it will help you boil down any complex user utterance coming in into one of these 4 least common denominator concepts and return them to you as a datetime expression. So given any user utterance, all you have to do is request a datetime expression and it will distill it down to one of these 4 buckets. So things like today, tomorrow, Halloween will be simplified into a date and resolved to a specific time, so to a specific moment. So Thursday, October 31st, for example. Tomorrow at 8 p.m., at 7 a.m. on November 2nd are all instances of date times. This week, next month, in June 2001, these all go to becoming date intervals. And finally, we're very grateful to not have to do this work. Date time intervals can be resolved from complex sentences like tonight or after lunch, which tend to be more ambiguous. So let's go back to the Bixby studio and see what this means. I'm going to switch over, and I will close this search capsule we just created and open the movie agent capsule. You might be familiar with it. It's published on GitHub. We've been using it throughout SDC, including at the Code Lab, so maybe you had a chance to play with it. If not, I encourage you to go clone it and check it out. And essentially what we've done here is in this capsule, we have imported viv.time as time. And then we've done a full integration so that you can go to the simulator, and I'm going to clear it, compile it. And you can ask things related to time, for example, recommend a movie from last spring.
Here are a few movies released in spring 2019.
So now the movies are filtered to fit that release window, and each one is displayed along with its release date and its runtime in minutes. So how did we achieve this? Let's have a peek at the debug console. And first things first, let's check out the conversation section and see how it was slotted. So we have recommend a movie from last spring, where last spring is a time.datetime expression. So how did it know, amongst all these words, that last spring was the part of the sentence related to time? Well, we gave it some training examples. So if I show you the training for this capsule, and I filter it to show you all the values that came from that time handle that we created. So V for value, and then time, and then I'm using the wildcard star to show you everything coming from that library. We see a few examples here. Recommend a movie from last year. Last year, date-time expression. Find a 2010 movie, date-time expression. After Halloween 2015, date-time expression. Every single thing is just a date-time expression from our point of view here. We can add any silly thing that the user might want to say. For example, find movies released this morning. Add it, and it already knows because it has enough training and it's been able to generalize, and the time library provides specialized patterns in the natural language that this morning is probably a date-time expression, which is correct. So we can go ahead and accept that suggestion and save it and send it to the simulator.
I couldn't find any movies released this morning.
So fair enough, but we can see in the debug console that this morning was properly understood. So let me just show you here. This morning was understood and was resolved by the time library here into a date-time expression. And of those 4 concepts I showed you earlier, it correctly identified that this morning is a date-time interval with a start and an end. And if you're really curious, you can expand and look under the hood by showing the import executions and see all the hard work that you didn't have to do because the time library did it for you in coming to this goal. So now all we need to do is get a handle on this date-time expression. So we'll go to the find movie model here. And we'll see that the first input is of type time.datetime expression. We left it optional, and then we added this block here, which is a default select. So what does this mean? Say I were to comment it out and go back to the simulator. If the user were to say something ambiguous, say, find movies released in fall.
Which genre are you in the mood for? Which one?
Without more user input, the time library can't be 100% sure what did I mean by in fall? Do I mean current fall, or do I mean maybe next fall? So when cases like that arise, the libraries might return a list of options, and they will return them in the order that's the most likely. So if you're doing something pretty conventional with the library, you can probably trust that this order is correct and tell it to always pick the first one. So that's what the default select block here does. It tells it to always pick the first one to reduce the friction on the user from having to do this selection. So if I run it again,
here are a few movies released in
I didn't get this
2019.
And the user could always go to the understanding page and change that selection if that's not the fall that they were referring to. Then one other thing I'd like to show you is what if I made this input required? Now the action won't be able to proceed without having a date-time expression. So if I just said find movies here,
I need a date-time expression to continue.
We get a default prompt. We didn't add any training for this prompt because we just triggered it now by adding the required cardinality constraint. But already we can talk to it and we can say early September 2010.
Here are a few movies released September 1st to 5th, 2010.
And thanks to the training in the library capsule, this sentence was recognized and resolved without us having to add any specific training. However, it would be nice to polish this screen and maybe even have a visual way to ask the user to input their time. So what we can do here is create a new file and add an input view, have it match this prompt. So this is a prompt for a time.datetime expression. We can override the message with whatever we'd like. I'll just say when. And we can render special widgets from the library. So here we have a calendar, and we will request for a time.date interval, because that's what makes more sense in the context of movies. So we'll have to allow a range of dates to be selected, and we'll want to lift a restriction by default that blocks past dates. So we're going to say it's okay to look for movies in the past. So if I go back to the simulator and ask to find movies, now it's prompting me for when. I get the nice calendar widget, and the user could decide to use the hands-on mode to select a date range.
Here are a few movies released January 2nd to 27th, 2017.
All right, so now we have all our movies filtered. We have our handle for the datetime expression in the movie model. We can do whatever we want with it in the action. So if we look at the action for find movie, we see that we wanted to hit the MovieDB API and pass in a release date range, and we had to format it to fit the API's signature. So essentially, once you have the datetime expression, you can do whatever manipulations you want in your code in the action implementation, and there's a handy JavaScript module called dates that you can import to help you do this. So dates will allow you to inflate the datetime expression into a JavaScript object. For example, here we're inflating a date time, and then it provides a bunch of functions that allow you to do comparisons. For example, zone date time is before or equal to now. It allows you to do calculations, duration until now and this day. It allows you to even modify that object. You can do all the calculations you'd like, and then when you're happy with it, there's a bunch of formatting functions to convert it to whatever format you need. So in this case, it's just the standard time-formatted string that we pass to the parameter in the API. So then the API call goes out, we get the list of movies, and then we parse them out and compile them into our results, which is a list of movies, each one with a release date. And the way we define this in the models, if I go to the movie model, you'll see that the release date is a time.date, and the movie details has a runtime, which is a time.period. Now, of course, you could say a runtime is just an integer. Why don't I just put an integer here? Why would I go in and use a time period? Where there are some advantages in using the distinguished models from the library capsule. For one, you'll get all the views and the dialogues that are already defined in that library. So you'll notice if we go into one of these movies, the date here is formatted to fit in this grid to be short and succinct, and then the runtime displays the word minutes beside it. So back to the debug console, if I have a peek at the layout, and I see here 100 minutes, let's jump to the file. 100 minutes came from this line here, but nowhere does it say the word minutes. Actually, I never even mentioned the word minutes once in this entire movie agent capsule. Instead, I request the value for the runtime, which is a time.period. And Bixby goes into the dialog registry to see if there's an entry there. And it so happens that the time library has defined and registered how to talk about time periods. So we got the word minutes appended to the end of it. And maybe if we use a different language, it would be a different word and it would be prepended to it. So all this work we don't have to do. We can just request the value from the concept and we get all the dialogues for free. In addition, there's a bunch of expression language functions you can use to work with those time concepts. For example, date time allows you to format it to a standard pattern. So here, month, day, comma, year, and this is how we got released January 27, 2017. So that sums up how to deal with the time library. Let's go back to the slides and do a quick recap. So in terms of models, you just have a look, get familiar with the most important ones, and then you see how to train in your capsule using the concepts from the library capsule. So in this case, everything in the natural language world, we just annotated to a time.datetime expression. Similarly, our action just had to request an input of that same time.datetime expression type. Then there's a few views we were able to use. There's a calendar, which I showed you. There's also a time picker with the sliding wheels to pick the hour, the minute, AM, PM. In the action implementation, we were able to inflate the time and then do comparisons, calculations, modifications, and finally convert it back to whatever format we wanted. And we did this by importing the dates JavaScript module. Then in the modeling, we can feel free to use any of the concepts from the library to benefit from having the layouts and the dialogues that were registered by that library. And in the expression language layer, there's additional functions that allow you to do even more calculations or even more formatting at that level. So moving on to the geo library, you take all those same principles, but you're using different concepts. So it's pretty intuitive, but the only difference here is that in natural language training, instead of annotating everything to a datetime expression, we would train everything to be a geo search term or a current location. Then in your action inputs, you have the choice. You can either request a named point if you want to work with a point with a radius for things like a destination or somewhere to go to, or you can request a search region, which will be a shape of an area that you probably want to search for, say, businesses in. The views provide, as you'd expect, a map widget that you can draw pins on. There's also an autocomplete widget that allows the user to start typing an address and then provide suggestions that would match it. In terms of action implementation, just vanilla JavaScript should be all you need, and the properties you'll probably want to access are either latitude, longitude, radius, or the name for that concept, for that resolved geo entity. And then you can use whatever models you want to benefit from their dialogues. And there are a few more expression language functions that you can use to either get the user's current location, to calculate a distance between points, or to check if a point is within a certain area. The profile library is even simpler. All you have to do is decide which fields you want to use, so the user's name, email, phone number. Then the README will tell you how to write an intent to get access to those fields, get that data. The profile library will take care of the views. It will create, as needed, a contact information form for the user to fill in text boxes, for example, name, then phone, then email. And if you switch to hands-free mode, it will automatically split that form into separate pages so that the user can enter all these fields one by one. So first they would be prompted for the name, then the email, then the phone number. And there's tons more libraries. Here are just a few of the more common ones. There's core, which provides a bunch of primitives that can be handy. There's money, there's measurement, there's contact. Then location is a super capsule that allows you to search through both contact and geo. And there's the audio player capsule for streaming audio files. So the final building block I want to talk about are sample capsules. These reside on our website, bixbydevelopers.com, and its sister GitHub account, github.com/bixbydevelopers. So you'll find there some complete walkthroughs. For example, the movie agent capsule that we just looked at is all there for you to play around with. It even has a puzzle section where you can do some hands-on exercises to learn more about Bixby development. And then there's the Space Resort capsule, which shows you how to find a hotel around Jupiter, and then goes on to give an example transaction end-to-end for users to pretend to book a hotel room. And then there's also a bunch of sample capsules which focus on a single smaller feature of Bixby platform at a time. For example, there's a sample capsule that would just do error handling or HTTP API calls. So you can use these, you can for reference, and then copy over the code snippets that you'd like and get up and running even faster using the capsules. So that completes my session. We've covered the templates, we've covered the library capsules and the sample capsules. Now I encourage you to go out and build something awesome and go publish it in the marketplace. And if you need even more incentive to do so, you should check out the BixbyDevJam.com, which will explain all sorts of sweet prizes that you can win for building capsules and publishing them to the marketplace. So thanks a lot, and I hope I get to work with you all in the future. Thank you.